Right, hello, you're right. Today is going to be quite a quick lesson on my part about Group 7. So here's the Group 7 folder. And because this is a practical lesson, we're going to very briefly brush over the theory. I'm going to get you to watch a video and you're going to make notes on it. Then, when we go back to school at some point in the future, we will actually do the reaction and the practical, so we'll get to go over it all again. So there isn't that much to do this lesson, and it'll be quite abstract, so it might be difficult. But I promise you, when we go back to school, we'll do a reaction involving the Group 7, and we will do like a recap lesson. Now, it might not be straight away, but it will be at some point. So let's go straight into the PowerPoint. So there's the lesson objectives, if you'd like to pause. Now, Group 7. So if we go to our periodic table, here's Group 7. So on your periodic table, it's fluorine, chlorine, bromine, iodine, astatine, and tennessine, which is because these are we have synthesized these in the lab, but you will never find these naturally in the earth because they are extremely radioactive. So really, the only ones you should think about are the first 1, 2, 3, 4, 5. Now, here they are, which you can see from your periodic table that you've got. Now, this is what they look like. Chlorine is a pale yellow gas. Bromine is this dark reddish brown liquid, and iodine is this silvery sort of solid, silvery grey solid. Now, we need to know halogens are non-metals, they're brittle, and as an element they are poisonous. Okay, so there are the colours. Now, the word here, volatile, what that means is they turn to a gas easily. If something is volatile, it will turn to a gas very easily. I'll give you an example. Petrol is volatile. How do you know this? Every time you go to a petrol station, you'll be able to smell the petrol quite easily, and it's quite strong. So you know, because it turns to a gas quite easily, usually you will be able to smell that liquid from quite a distance. It is volatile, and that is why it is quite flammable. Okay. Iodine starts off as a solid. If you heat it, it will turn straight to a gas. It skips the liquid phase. Okay, it goes from solid straight to gas. We call that sublimation. Now, I'm skipping over a lot of this information here because you're going to watch a video that will explain it in more detail, and then you'll have these notes that you can refer back to if it's going too quick and you get confused. So, a little quick task for you. What is the state of each halogen at room temperature? And room temperature is 20 degrees. So pause this, have a little think. What state do you think they are? Okay, hopefully you've paused it. You've had a go at guessing the state, and we should know that you've got a choice of solid, liquid, or gas. So, fluorine at 20 degrees, it will be a gas. So will chlorine. Bromine will be a liquid because 20 degrees is lower than the boiling point. And iodine will be a solid. Now, the last thing we need to know is displacement reactions. Now, I'm going to go over here to my periodic table. I'm going to tell you that fluorine is the most reactive halogen. Okay. Chlorine is less reactive, bromine is less reactive, iodine is less reactive. So the one at the top in group 7, so fluorine is the most reactive and astatine is the least reactive. Now what happens is we can have reactions that we call displacement reactions. So let's use the example of the Hulk. You can quite clearly see the Hulk is much stronger than this bear here. So what happens if the Hulk wants the dolly mixtures, he's going to take them, right? So you've got a compound here. So this is representing a compound. I'll get my laser so it's easier to see. This represents a compound. The bear is trying to eat the dolly mixtures. Okay, they're his dolly mixtures. The Hulk is the element that is super strong, comes along, throws the bear out the way and takes the dolly mixtures from himself. Okay, So now you've got a new compound with the more reactive thing has displaced it. And in this case, the bear is iodine, the Hulk is chlorine. Now, again, here, we've got the Hulk and we've got He-Man. Potassium chloride, again, look at the Hulk compared to this guy here. The Hulk is obviously stronger, right? So you've got chlorine, which is more reactive than bromine. So the bromine is not reactive enough to displace the chlorine. So He-Man is not tough enough to fight the Hulk, so the Hulk keeps all the Stolly mixtures and eats them for himself. Now, this explanation is a lot easier to follow in the classroom when we actually do the experiments ourselves. So, instead of this task here, there is a video that I want you to watch. It's this one. It's 5 minutes long, well 5 minutes 30, and I'd like you to watch the full video and make notes on various things that you think are important. But at about 1 minute 30, it will start to go into reactivity, and it will go onto the displacement reactions, and because they've got nice little diagrams, it explains it a lot better than I can from home. So I'd like you to watch this, especially the part about the displacement reactions, and you'll see that the displacement reactions kind of stop about 4 minutes in. So that's really the bulk of the video, and it's the most important bit. So watch the video, make a few notes on it, see if it'll help you understand the displacement reactions, and then when you get to this slide here, this is another way of displaying all of the displacement reactions at once instead of doing them one at a time. See if you understand why chlorine will react with potassium bromide, but bromine will not react with potassium chloride. Okay. After you have done that and watched the video, okay, I made some notes. That is all you need to do for today.